Okay. Hi all, nice to be here and nice to present this presentation. If you can see my slides, I can start. Yeah, great. So I'm working in Bright for 2 years as a Crystal developer, and my background, it is a C++ background for many years of C++. I'm an experienced Linux user also for 10 plus years probably, starting from something easy and ended up with not trivial but really interesting distributives like NixOS that I would also definitely suggest to everyone. In any case, after long C++ experience, I jumped into Crystal, worked with a Bright security company, and will share with you benefits, drawbacks, problems, challenges that we face with during our development, and benefits that Crystal introduce into our project. Let me tell a couple of words first about the company. It is a Bright Security, about product. It is a Bright Security dynamic application security tester. It is more HTTP client than HTTP server. So it's not a lucky website. It's not a lucky web server or something like this. It is more utilize HTTP client technologies and sometimes low-level HTTP client technologies to search for vulnerabilities and to scan infrastructure of customers. And infrastructure sometimes is really tricky, not honor HTTP protocol, and different other use cases happens. We use Crystal as our main first citizen language, mostly for core functionality, not for hosting website, but for actually performing the attacks, setting up web crawler, performing crawler pages, and all this main core functionality of the product. And of course, faced with dozens of problems and benefits during working on it in Crystal. So that is. And first, let me start from the things that I love Crystal for after these 2 years of development. Initially, it was a bit confusing for me after C++ syntax. I was not familiar with Ruby. I was not familiar with many concepts of development that usually we do in a Crystal lang, for example, yielding and not a concurrent programming, but yielding proc stuff was a surprise and very not usual for me in the beginning. But finally, I used to it, and now I can say that I miss it when I start program on C++ or mostly any other language again. But anyway, about the aspects that I do love on Crystal. First of all, it is a performance. Comparing to other languages with similar level of jump in barrier, so with similar level of pretty syntax, Crystal, I would say, is the best in the performance, because Python also have pretty syntax, but Python is slow. The Ruby is also slow, and Crystal is fully compilable language that gives you one static portable binary that you can just copy to another Linux machine, and it will work without dependencies, with easy packing and all these things. Other popular languages, maybe like Node.js or, as I told, Python, will bring with your program also half of the world into the final Docker image that will probably something like 100 or not 100, up to 1 gigabyte sometimes. Also, Crystal have very expressive syntax and wonderful concepts, so that old architectural patterns that we usually used to apply in object-oriented programming languages like Java or C++ are looking a bit different here, not a bit, much different. So the approach for operating architecture is changed a lot. I would probably love to see some talk from somebody about the way how, for example, Goff patterns would look like in Crystal, and most of them we don't need anymore. They are not actual, not just because it is 2023, also because of the concepts of programming that Crystal involves. The boilerplate of the code became much less than in C++ as I used. And standard library. Yes, it is well documented, but that's I used to. That's nice. In many mature languages, standard library is well documented. But in Crystal, standard library is not only well documented. In Crystal, standard library, it is also very good written, not just because it is effective, but it is very good written for reading, so that I can, if I don't understand, if something is not covered by documentation, that is not usual, but I can go into the standard library code, into the compiler code, read and understand it. That is completely new experience for me after years of C++ development. If somebody had an experience of reading std library code in C++, he can understand me. It's very not easy reading. It's a lot of unreadable code that is very effective, very good, but completely unreadable. And donating into standard library of C++ is complicated. Besides, Crystal gives you a good experience of working with it. So you can read it, modify it, give a donation, and monkey patch in case if you need it. That's dialectical point. I will talk about monkey patching a little bit later. We had a bunch of experience with it. Also, my global feelings of using Crystal after C++ is yield. Is a new concept. It was a new concept for me, and it makes you addicted. After understanding that you can do a callbacks and iterating such an easy way, any other languages usually don't give you such kind of usability. Either it is going to be a huge boilerplate code to provide yield functionality, or it's not possible at all. Usually just a lot of boilerplate code, so that other types of callbacks, other types of iterators become more usable. But in Crystal, most of the things are based on yield and yielding some procs, some blocks. And it is very useful. And I like this concept a lot. It changes away how I am doing my day-to-day work. Then easy performance with native fibers, so that Crystal don't really support multi-threading yet. It is in a preview stage, and we all waiting when it is going to be released. But the fibers gives you an ability to set up a very high performance application, as we already seen on several examples on this talk. So the guys from Joystick TV and from MQ setting up a very high performance applications. They process a lot of data, and all it is done in one thread through the fibers. And there are minimal boilerplate to use fibers in Crystal. Instead, in C++, if you're working with threads or any other concurrency, it becomes really hard to implement such kind of applications. Then a simplicity of a build system was a big surprise for me. After years of working with a huge CMakes, after huge make files, CMake files, different configurations, and other stuff, that is the usual situation in a C++, just a single shard YAML file that is compact and easy to use. That's a very simple build system, and it is awesome in Crystal. Then the thing that I always love, and that's why I usually start to use NixOS, it is that Crystal does not pollute your system. No artifacts are left after you install Crystal, except actually the binary that is located somewhere in user bin, the shard, and cache that also can be cleared or saved in temporary folder. So other interpreted languages like Python or Node.js usually pollute the system a lot with all this standard library or virtual ends or whatever. In any case, when you install the language, you also put a lot of different files in many places on your operation system that I definitely don't like. Besides, Crystal gives me very nice minimalistic experience so that my system is still clear after installing and work with it for a long time. That's why I do really like. Then a clear error messages, also comparing to a C++ experience. If any of you guys ever had an experience with it, the error messages in a C++ usually terrible, especially when it is a mature project with the templates, with all these things. In a Crystal, usually every error message, even in very beginning of my experience in Crystal that I've seen, it was easy to understand and easy to fix. But unless you start using macros a lot, that I would say a big evil in Crystal, and you should try to avoid, not avoid using macros at all, but try to avoid using a lot of them, because when the language that you're writing on starts to be some kind of DSL, but not a Crystal, it is hard to work with such environment. And another thing that I don't like Crystal, it is a monkey patching actually. Not monkey patching of standard library or some shard, but a fact that class can be implemented in many places, so spread it across a project. And you never know where else, for example, this variable is touched, what other functions this class support, and you don't see the full definition, or at least full declaration of the class. Sometimes it is weird, and it helps you to do some quick fixes, to hot fixes, maybe to introduce some functionality to standard library or to shard that you're using, but generally it is a terrible practice and would be nice to avoid it. Then let's go further. So my talk is mostly about the applying Crystal in a production for real cases and spreading Crystal actually to the other developers. The things that we are thinking about when we choose a language for a project, first of all, it is, I would say, not a syntax. First of all, it is a community, an ability to find the developers on the market. It is a painful point for Crystal, and usually that's why management don't really like the idea that initially we choose the Crystal, because to find a new developer, it is always a complicated task. We never can find a native Crystal engineer. It is either Ruby engineer or C++ engineer. In our case, sometimes it is Go or other languages engineer. But in any case, community of Crystal is wonderful. And the very good thing in this language is that you can get in touch with project maintainers directly and easily. And project maintainers, the Crystal maintainers, would help you in case of any problem in your project. It is very useful. And in C++, probably you don't have such an ability. The language is very mature, and there are no like one contributor to it. But instead, there are tons of C++ engineers in the market. In C++, that's not a situation yet. I hope yet. And as soon as it will be a different situation. Then the performance. Crystal is a winner in this place, so that you can set up high-loaded application. You can implement it without calling the C libraries every time when you need to do some high-performance calculations. So Crystal is compiled language. It's compiled powered by LLVM, and that's very good. So performance is on high level. Then infrastructure and libraries. I will talk a little bit more later about it, but that is what I really like in Crystal, that the libraries came from 3 points: the Crystal shards, it's rather wide, the Ruby code, and the C libraries. All these 3 sources can be integrated into Crystal, so it gives us a huge freedom of choosing and huge variety of the libraries that we can use. And the syntax. Actually, the first point that there are not a lot of Crystal engineers of the market, usually easily fixed by the easy jump-in barrier to start programming in Crystal. It is a very easy to start syntax. It's not complicated concepts. So this is language really for humans. And any engineer with very basic, not basic actually, with experience in any other languages can jump into Crystal development really fast without serious surprise. And that is a process that currently we are experiencing in our company, that we have many developers also in Node.js, in Go, and all of them are learning Crystal, and this is rather painless process, so that even not familiar with Ruby before, you can jump in and start programming. So let's talk about the upsides of a Crystal, the stories in a project when we feel the benefit of usage of a Crystal language. And the first one, it is an adopting of Ruby and C libraries. In this particular case, it is about Ruby, but C libraries as well. You all know these comics about import anti-gravity from Python, and I would say that Crystal is doing pretty the same. First of all, as I told, you get sources of a bunch of code, bunch of libraries, infrastructure that is written in other languages, especially in Ruby and in C. And it is a huge infrastructure. When you have all these resources, you usually just can do something like import everything you want, require in our case, anything you want, and it will work. Maybe with minor modifications, creating either C binding or porting Ruby code into Crystal, that is also can be done trivially. In our case, we experience it with it many times. The biggest probably one was a porting of a Ferrum. It is an Chrome Developer Tools protocol that was implemented in Ruby, but not implemented in Crystal, and it was seamlessly moved to a Crystal, and we was able rather quickly move our implementation from Firefox Marionette to the Chrome Developer Tools within already almost ready to use Ruby code ported to Crystal. And that's a very good experience of utilizing Crystal instead of any other languages in a project. Same we do for many other games as well. For example, public suffix previously was the Ruby game. Now it is a public Crystal project, also with minor modifications. And that's wonderful. That's a very good story of adopting Crystal in a project. And the second one, we don't have native Crystal developers. As I told all our team, it is either C++ or Ruby developers. The learning curve of Crystal is not really straightforward, so you can create an HTTP server after 5 minutes of reading the documentation, and it works. It is rather high performant. You can process incoming HTTPs and do the router as you need. That's wonderful. Set up shards, so you have very quick jumping. Then, of course, you have a curve that you don't find the loops in the language. That makes you confusing. Then you catch the yield concept, and when you understand the power of it, you feel very confident that, wow, that's a completely new way of programming. Then you find macroses, and it makes you very confusing. So usually The macro code that you need to debug is hard. And Crystal compiler helps you a bit. It unwraps macros during compilation in case of problems, but even then, it's not easy to understand what is going wrong and how it works. With macros, you can create a full new DSL language instead of Crystal, so that if some developer came from maybe sometimes, usually when developers came from Ruby, they understand macros and like to apply them and create some kind of, looks like useful way to do the things, but it's not a Crystal anymore. It is some DSL. And when you make errors in this DSL, you don't understand what is going on because errors are actually in Crystal code. Errors are not in DSL. That's weird. Then you understand how the macros works, and you like feel a good power. But now all your colleagues hates you because nobody can debug or support your code. And the last thing that is a bit confusing, it is that you never know where variable is defined. There are tons of, like dozens of ways to add a new variable or new method. With macros, with define, with also the spreaded class as well helps with it. So IDE usually don't know where the variable is defined. The only thing you can do it is with grep. I didn't try language server. Maybe it would help a lot. I will definitely try. But this is a big pain when you, first of all, when you start programming in Crystal, you don't understand where is this function. Is it a function at all, or it is a variable, or it is a property, or it is a getter? In case if it is a getter, is it create like a function and the variable and how it works, where it is stored? Not useful after these other static languages. The dialectical part of C++ and Ruby developers is that we have a holy wars all the time because it's totally different approaches. C++ and Ruby developers used to write the same things different way. The good part in the scope of it is that after all these holy wars, finally the Crystal catches all the good things from both approaches, and code became much mature, robust, and simple for understanding for both C++ and Ruby developers. But that is a not easy process. When developers came from two different worlds, it's usually not easy to find the common language in between them. Crystal, actually, it is a common language between. And the third success story of application Crystal, it is that application security engineers, application security researchers are able to utilize Crystal to do the researches and to write the code of a new attack or modify an existing attack, whatever it is, not in Python or whatever they used to do it, Postman, but in a Crystal from scratch. The jump in barrier is low enough to start program, not even by a developer, but by an application security engineer that don't have experience of the writing the production code. So, but even after this, the code that these guys are writing, maybe with some minor modifications because of the robustness, productionness, covering with specs, all these stuff that developers usually do except coding, can be moved into production as well. That's really good. But there's the dialectical point. Sometimes the managers start thinking that we don't need developers anymore if application security researchers can write the code. That's not correct, of course. We still need the developers. Application security engineers can write a code, but it's still not a production code, but very close to. And that's a very good point of utilizing such a low, easy-to-use language as Crystal with a rich standard library, especially for an HTTP. The next part, it is the story of jumping from multi-threading to one-thread environment. So mostly our main utilization is of course input output. We send tons of HTTP requests, receive response, analyze them, and usually we don't have a lot of to do on the processor. So initially we was utilizing -d multi-threading preview. It was not a good experience, and we decided to jump into the one-thread environment. And as a surprise, it was a surprise for me that we didn't catch any problems at all. The move was very seamless, and no bugs were found that was related to it, no deadlocks, no problems even with the performance, no performance degradation at all. We just removed a flag and it was just work. That was a surprise for me. All synchronization primitives was still there, but they became just stubs, so they don't do their actual work in the one-thread environment, and still no performance degradation. And our life became much easier and stressless with the one-thread environment. And the next story of beneficial of a crystal, it is the power of C bindings. We, as I told, it is the same as the first story, actually. We utilize a lot of C libraries wrapped with the crystal bindings to C. It is easy to use. And can just use it without any problems. That's a good work. That's a whole infrastructure that was written for C initially can be utilized in Crystal. Especially, it was a good point. It's not our binding that a Crystal 1.8 moved to a new version of regex that increased speed of and performance of regex significantly, and we feeling it in our product. If I have a couple of more minutes, let's go through the pain points of adopting Crystal in a project. So the story one, yeah, please. Sorry. So the story one, it is multi-threading preview. I feel multi-threading in a Crystal is a little bit weird. I'm waiting it to become a first citizen part of a Crystal, so removing preview part here. But the problem that I see in a multi-threading of a Crystal, that it is both cooperative and preemptive multitasking. That's not the way how I used to work, but that's not the point. Everybody used to work in their own way. The problem that we catch is that we catch both problems of cooperative multitasking and preemptive multitasking. So we catch in case if in case of fiber, don't call yield in some loop and do some either infinite or very long operation. So all other fibers that are separated on this thread cannot catch the CPU. And both of these problems makes a life really hard. And also, different shards that you utilize may not support multi-threading, so they don't even know about it probably. So that also can be a problem, that even if your program is works good, somewhere inside a shard, inside your dependency, there could be a problem, but multi-threading will be spreaded to this shard as well. Finally, we decided to move from a multi-threading environment to one thread. And as I told, we didn't feel any degradation in the performance. Probably when multi-threading will be the first citizen feature of a language, we will jump in again, but we will do it carefully with, if it is possible, not just introduce a flag, but step by step, starting from some small points, actually to increase performance, but not just to utilize multi-threading because it exists. And the next story, it is a memory issues investigation. It was a big problem in our project, the leakage of a memory. Actually, it was mostly not a leaks. There was leaks as well. It was like high memory consumption because of fibers are not synchronized properly. Very easy way to catch some kind of a leak. It is spawning a new fiber in a loop that grab a context of some big object, and another fiber that utilize the results of these multiple fibers that are spawned in a loop. And in case if the reader fiber is slow and many writer fibers are fast, so you start leaking. The objects are not the objects. Oh yeah, sorry, I will wrap up in a minute. The objects are not clearing. Actually, they are clear, but they clear slow, and memory grows faster than you consume the object. Finally, we was able to beat it with the help of Manas and help of wonderful tools that Manas provided. I definitely suggest everybody to use it. It is a perf tools that you can find in the repository. The regular tools like Valgrind or Perf are not really helpful, especially when you catch a leak on hours of project work. So that's a big pain that we faced with. And the last one big story, it's frequent new versions. We had a situation of a monkey patching, a lot of monkey patching on standard library because our project is old and it was starting when Crystal was 0.9 or something like this. And then after we moved to a new release, and we got new release of Crystal mostly every 1 or couple of months, sometimes we can catch a bug in a production because our monkey patching of standard library code is compatible in a compile time, but actually not compatible in the runtime. And we catched these bugs in a production. And it was a terrible long debug situations, long debug of multiple developers together looking into the code and why it's happened. So my general suggestion, don't use monkey patching. It can cost you a lot. And to wrap up, let me list down one-line pains. So sometimes the location of an object can surprise you. That if it is on stack, on or heap, you need to go into the definition of the type, if it is a class or if it is a struct. And sometimes in type hierarchy, you see that it is a struct, you copy it, but inside a struct, you got classes that are actually located on heap, and you may catch problems with this copying, especially in multi-threading environment. Then require everything is never able, so that you don't understand the dependencies between your components anymore. Try to avoid these things as well. Overusing macroses, big evil, I already talked about it. The one small pain that I feel is that it is lack of main function in Crystal, so that you don't really know where the entry point of your variable of your program. It just starts reading from scratch. Spawn same thread false by default. It's also one small pain that I feel that I would like to be same thread variable in spawn false by default. It would be much more useful. Dozen of approaches to define a variable, their lack of specs out of the box, and monkey patching. But also let's go through the one-line gains and benefits. Yeah. Yeah. Okay, sure. I'm sorry for this. I'm sorry for. Yeah. So I'm wrapping up with thanks for all. In case if you have any questions, feel free to get in touch with me with a GitHub or email. My GitHub is listed in the first slide of a presentation.
Discord that we can use to. There's the chatting Discord we can use for questions. Alexander, are you there in the Discord channel to answer questions? Alexander, can you hear me? No. Alexander.
Yeah, thank you. I can answer also questions in chat as soon as I'm doing online presentation. So feel free to ask it in a YouTube chat. I'm here. Thank you.
Thank you.
Yeah. Thank you all. Bye.